So for example number 1 from 4.5, they give us an equation f of x is equal to the square root of 1 plus x. And they give us some information, x equals 1, and then they want us to find the square root of 1.02. This is the important part of it. So for 4.5, when we do linearization, or Newton's method, what we want to do, and what this is used for, is for computer programming, and sometimes we can do things in our head without a calculator. Clearly, if I wanted to find a precise value of the square root of 1.02, I need a calculator to do that. We know that it's very close to 1, you know what I mean? We know that it's very close to 1, but we don't know how close. And to find the answer to this without a calculator is kind of challenging. So what we're interested in is we want to have some sort of way to figure out what this is. All right? So this occurs when, if I rig up the problem in the real world, what I would do is I would rig up an equation that I could solve without a calculator that would be very, very close. So what's very, very close to 1.02? 1.00, right? 1.003 is too close, but if I let x equal 0, I'll get this. So what I want to do is I want to find some sort of relationship between this function and this function that I can kind of do in my head without using a graphing calculator. So that's where linearization comes in. Okay? So what I want to point out to you guys is that if I graph the original equation, if I come over here and I graph this original equation of the square root of 1, was it plus x?
Yeah.
Yeah. If I graph that, and we're just going to do a standard zoom, I get the graph that looks like this. All right? Now, for this practical application, I'm interested when x equals 0. So now on my graphing calculator, when x equals 0, oops, got a bunch of stuff here. When x equals 0, y equals 1. Okay? Now what we're really interested in though, is when x equals 0.02. Okay? Because 1 plus 0.02 gives me the square root of 1.02. Does that make sense? You guys with me so far? Okay, good. So now, if I look at the graph, I'm going to zoom in very closely. So what I'm going to do is I'm going to change my window. By the way, while I'm doing this, if you guys want to get out your calculators and do the same thing, that would be great. But I'm going to do from alignment, let's do 0 to 5. Okay? Actually, yeah, let's do it like that. So I'm going to graph in like this. So this is that same function, but I've graphed in really, really, really close. Okay? And so now if I hit trace and I hit 0, that's where I'm at. Okay? You guys know where we're at? What I've done? Now what I'm really interested in, I know that this equals 1 right here. But I'm interested in x equals 0.02. Okay? Which is very close to it. In fact, to give you guys an idea, I'm going to zoom in a little more. I'm going to go to x equals 0.05. So now we're really going to zoom in. Okay? By the way, what did our curve, what is it starting to look like as we zoom in closer and closer and closer?
Straight line.
Looks like a straight line, right? Okay, so if we zoom in closer and closer, now when I hit trace, Well, when x equals 0, y equals 1, no surprise there. Let's see what happens when we do 0.02. Y equals 1.009. Now, in reality, that's what we would do to find the answer, but remember, your textbook wants us to do this without the calculator. I'm using the calculator to show you guys what this looks like graphically. So what we're going to do is we're going to use the tangent line of the function to do a linear approximation. So now watch this. This is where you'll want your calculators. Everybody have this graphed in on your calculators, right? So we have this graphed, the square root of 1 plus x. That's what we see on the screen, okay? What I want to do is I want to write the equation on the tangent line and then see what that would be. Evaluate it at x equals 0.2. Now watch this. If you hit second, program, it pulls up the draw menu. You see anything up there that looks familiar? Tangent. Did you guys know that your calculators could write the tangent line? And we could skip all that work I took so long.
You're telling us this now?
Yeah, I had to make sure that you learn how to do it first. But if you want to take the shortcut, you could do 5, and if I hit 0, my calculator is going to draw the tangent line and write the equation for me when x equals 0. So when I hit that button, that second line you see there on the bottom, that's the tangent line. What's the tangent line? Right here. Y is equal to 0.5, or you could say 1/2 times x plus 1. That's the tangent of the curve at x equals 0. Now, we've got all this like 0.00, all these zeros in the 625. That's because it uses like an approximation method, right? Remember that approximation method that we used earlier? That's where that comes from. Now, what do you notice about the tangent line and the original curve when we're zoomed in this tight? They're almost the same. All right. So now that I've shown you that, the process to do linearization, according to your textbook, is, hey, let's do a little review here. To write the tangent line, we started off with y minus y sub 1 is equal to the slope times x minus x sub 1, right? And then Mr. Adams, because I'm a little lazy, what I do is I do this. I always think of this as this, right? Okay? Does that make sense?
Yeah.
I want to show you something. Your textbook says that we can do the linear approximation by using the tangent line. What is y sub 1? Well, let's go back to the original function. If I let x equal 0, right? What I'm really interested in is this value here. But I'm going to say that a equals 0. So if y sub 1 is my y value of the function, I'm going to clear out my tangent line. What is the y value of this function at x equals 0?
1.
1. Right? You guys remembered that, right? So y is really, so when I think of this graph, and let me just sketch it so I don't have to keep going back and forth. We've got this graph that when we zoom in real tight, that's kind of what the graph looks like. And the point here, if x equals 0, well, it's actually right here, right? Isn't it a comma f evaluated at a? Right? And then what we're going to do is we're going to take the tangent line, which if we zoom in real tight is almost on top of the original curve, right? So I'm going to write the notation a little different. I'm going to say that y sub 1 would be f evaluated at a plus, now what's the slope? It's the derivative. So I would say f prime of a, the derivative evaluated at a, times x minus x of 1 is a, right? Because we're talking about 0. So whatever value they give you for x is a. And so this is the formula right here that they have in the textbook. Okay? So the process to solve this, in other words, we want to figure out what is 1.02 and figure out what that is rather precisely without using a fancy calculator. Okay? We want to be able to do that in our head. So, well, we can find out what f of a is because f of a is the original function, f of 0, and the original function that we came up with was 1 plus x or 0. So f of 0 is equal to the square root of 1, which is just 1. So I put a 1 here. And then f prime, this is the tricky part. If that's f of x, we got to figure out what f prime is. So f prime, if f of x is equal to the square root of this stuff, isn't that the same as 1 plus x raised to the 1/2? So then f prime would be 1/2 to the front, or put an equal sign there, times the stuff on the inside raised to the negative 1/2, and then the derivative on the inside, which is just 1. And we don't need to write that down. You guys see what I did there? Okay. So then I need to evaluate f prime at 0, which is 1/2, right? Because if I put the 0 in here, 1 to the negative 1/2 is just 1. 1 times 1/2 is 1/2. So this becomes plus 1/2 times x minus a, which is 0. So if I rewrite all this together, my linear approximation, does that look familiar? That was the tangent line, right? That the calculator spit out. I see some looks like this. So what I'm going to do is, let's do it again. If I hit second program, which gives me the draw, and I find the tangent line when x equals 0. Give it a second. When x equals 0, the calculator will find it for us. Hey, look, they write it a little different, but it's 0.5 times x plus 1. Same thing, right? So now, the point of this is just to go a little bit away from what x is. We were interested in 1.02, which means I would have to evaluate this function as 1 plus 0.02. Because that's what I'm trying to do. I'm trying to figure out what the square root of 1.02 is without using a calculator. So everything that I've written down on the smartboard, I've done by hand. So what I want to do to find this linear approximation is I'm just going to say 0.02 into my tangent line. What's 1/2 of this 0.02? 0.01. So this is a linear approximation of my function. In other words, the square root of 1.02 is approximately this stuff. Does that make sense to you guys? And how could I verify that? I could graph it or just plug it in the calculator, right? So if I look at my original function and I say 0.02, whoops, from the graphing menu. If I look at my original function and I say 0.02, I get 1.009. What did I do just using my brain?
You got 1.01.
Is that close enough?
Sure.
Yeah, that's pretty close, isn't it? So that's what linear approximation is. We're going to use linear approximation to get a number that's really close. Now here's the thing. This is the, well, it rounds it, but you can see how this is a more precise value. Now what we're doing is really on my calculator, if I quit that and I say, well, okay, what is the square root of 1.02? What should we get? Pretty darn close to 1.01. So that's what we use linear approximation